Ladies and gentlemen, boys and girls, and kids of all ages. We're back on the kayak motors. So, make sure everything's in focus here and like it's supposed to be. So, I don't know what that's all about. Anyway, this is a LED AC input 110, 120, output 12 volt, and 30 amp, 360 watt. So, and this is going to tell us what our motors are doing. Here's our two motors. Here's our two motors with the two counter rotating props on them. And they're 775 motors. I'm going to leave a link in the description where you can buy these. I'm going to leave a link in the description. I'm going to be a little bit more detailed. I'm going to try to be more detailed than I have in the past. And I'm going to share some of the problems that I have been going through with these. Now these are the end plates. These are, I still have to cut these off or trim some of this off, clean this up, get this holes in there, get this, that, and the other thing. And like I said, there's problems with, because one fits in one and one fits in the other, and they fit tight, but they were meant to fit tight. So anyway, that's neither here nor there. We've got everything we need. A lot of this stuff that I'm buying is made by Octura, RC model power boat fittings and stuff like that. So these props are glass filled carbon fiber. Now if you look at these two, they are in the same rotation. Now let's say both of these crank up like here, and as you see they're going to be pulling, so they're going to want to jerk the rudder to one direction. These are opposite, so whenever they pull, they're going to pull opposite of one another, so the rudder's not going to do anything. It's just going to, you know, stay steady. And not that the rudder on a kayak, not that the two of them are going to cause any problem if you don't run counter rotators. It's just some of them are loose, and once you cut it on, you hear that clunk. Well, this way you won't have to. Will it be an advantage power-wise or anything like that? I don't know. So we're going to address the bigger problems right now that I've been going through. So no further ado. Let's get started with this. We're on 0 amps, 12.44 volts. I'm going to shut this off when I plug these in. Now this one here, the red dot signifies positive side, and this is negative side. I've got these switched because of the rotation thing. Now, the vanes on the motor are straight. So these are kind of like drill motors or what have you. If the vanes are not curved in any direction, they're straight so they can still cool in either direction. So, and you can see this one pushing. We're running 1.95 amps at 12.4 volts. So I kind of went with a 12.4 volt, so to speak. and it puts out pretty good air, you know. So now this is a counter rotating one, and like I said, it's like it's bouncing a little bit because of moving the air. I actually restricted the air on the motor, and that's going to make a difference too. Even if you're doing this right here, that's going to jack it up. And just by blocking the air off from the fan so it can't pull any air, now the amps are going to go up. Now they're going to drop down. So we're looking at 1.81, well, it's kind of all over the place here, but you kind of get the idea. Okay. Now this one here is going to be in the proper rotation. Oh, unplugged the wrong thing here. You big dummy. Alright. And these are Dean's plugs, connectors I use. They're good for 60 amps. They're good for DC and what have you. So now this one here is going to be running the rotation that it's supposed to. The positive is going to be on the positive side, the negative is going to be on the negative side. So this is what it was intended to do. I'm not blocking any holes or anything. And 1.81, it's about the same thing. Not a whole bunch of difference. So that's good. That's good. See, they're both right on in there where they're supposed to be. And, you know, that's not bad. So we're going to take this off of both of them. And by the way, unplug. I have a switch there on a strip but messing with these little props, even though they are carbon fiber glass filled, they are very dangerous, and they will cut you. They are very sharp. And the reason I use them is they're very replaceable, they're cheap. I'm gonna leave a link to Offshore Electric so you can go look at all this stuff. This is just the coupler between a 5mm shaft, and that's what's on here, to a 3/16, what they call prop shaft, and that's these right here. Now the bearings and stuff, don't worry about that. And even in here they sell these tiny thrust bearings, very pretty, and they'll actually go, but then it's to take the thrust off the motor so you're not pushing on this back bearing with the commutator, and that's the commutator back there. So that's all they do. I'm gonna leave a link to Offshore Electric. Y'all get in there and look. These props are like $4 or $5 a piece. You can get them in what pitch you want, and then these are 1.4 pitch ratio, and I don't know the diameter on them, but let's say it's 50 millimeters in diameter. Not circumference, diameter. Then that's 1.4 times diameter equals pitch ratio for 1 revolution. So 1.4 times diameter of 1 rotation of this is movement forward. That's how that works. Okay, so we're gonna cut this motor back on. So about, I mean, like I said, hopefully, and let me check here. Hopefully y'all can see that. Now, even if you block the air off, you know, even when it's running like this, it's not going to do anything too much. Motors are not heating up at all. All right, now that's that's a correct polarity one. This is the reverse polarity one. And the brushes take a little bit to get wore in or polished in. Have quite a bit of little torque to them. 1.53, 1.7, 1.6, 1.3, about the same thing. Not a whole bunch of difference. All right, so I'm gonna go back to the one because people are gonna say, oh, well, you had that one on it. Well, I'm gonna go back to this one. Now, this is your seal housing. This is the reason I haven't been going any farther on these, because the holes line up right there. And the seal goes on it right here. And that's your seal. And it'll seal it right here so water doesn't get in there. This is a RC submarine seal. It's a 5mm ID, 15mm OD. It does have the spring in it, like regular seals would. But most submarines, RC submarines that is, will run a gearbox and a motor. Because of being more scale, the prop doesn't turn that fast. So they'll gear it down. And they go way down in the water. For every 28 inches you go down equals one water column inch. Equals 1 PSI. Every inch or 28 inches, or every inch is a water column inch to 28 inches, and then it creates 1 PSI. That's pounds per square inch gauge. And there's a lot of pounds per square inch once you go 28 inches down. I'm not really familiar how deep RC submarines go, but they have to seal a lot of expensive electronics and stuff like that, because if it doesn't come back up, you will lose it. So these seal really tight, and I'm going to show you exactly and they're both the same. There's no difference in this one or that one. We're going to try them both. So I'm going to want to try to catch, and hoping you can see this really good. Here, like one. Let's try this one. Now you see the problem I've been having. Just to overcome the seal on this takes an additional 2, almost 3 amps. Now, yeah, I can actually spin the motor, and this thing is actually, when you turn it on and off, it's going to stop abruptly because of the magnet pole. Now you're going to see this. It stops pretty quick because of the magnets in there are retracting on the armature. This is so tight. Well, I can't turn it. Yeah, there we go. You barely can, but now on this side, it's right when it hits that lip right there, but it still seals pretty good here. Now what I'm gonna tell you now is, when it doesn't hurt these things to get wet. In the RC car racing community and in the older RC boat, because most everybody runs brushless now. But back in the day when they run brush motors, they broke the motors in a glass of water to polish in the brushes. So getting wet is not a big deal. Coat it down. One viewer mentioned Corrosion X. Corrosion X is awesome stuff. Spray your motor down with Corrosion X. The thing of it is, the reason I'm building these like this is these 2 bolts. You take 2 bolts, you pull the whole thing out, you spray it down, you clean it up. You get the water out of it. You're going to have this plug, you're going to pull it, you're going to take it out, hose it down, clean it up, put it at if you do get water in it. And trust me, there's no, whenever they start talking about water resistant and waterproof is a hard damn thing to achieve. So what I'm looking at is, I'm looking to pull one of these springs out of here. And I want to test the motor, and this is the normal one, yeah. I'm going to test it with a spring out of it. If I can get it to where, and I've been looking for ceramic seals, they just don't, it's hard to get stuff that small. So not impossible, but we're still trying to, you know, make this stuff affordable, you know, for the average Joe out there, because trust me, I don't make very much money. And I've had to sacrifice quite a bit to have this shop, which I do enjoy it though. I'm not gonna lie, but this is the only place I go because I can't afford to go no place else. So let's see what it does without the spring in it. And that's a spring that retains this tight ass seal. Turn this one out. So now if you turn it this way, and if you was to cut that completely out and just use that front part there, it adds a little bit to it, but not that much. I've even thought about, and even taking the spring out really didn't do anything. I've been thinking about going with a carbon or buying some 5mm oil light bushing material, turning it down to fit in there. Get in there. I took this thing out one time. I've already done all this one time, but I wanted to show you all that I haven't forgot about this. It's just, there we go. It's just trying to seal it off. But the point I'm getting at here is, are you gonna have to seal it off? Because you're gonna have to go in it, you know. And like I said, I gotta clean all this up. I gotta clean all this up, make it more laminous, more smooth in the water and what have you. And I hadn't been neglecting it, but I've been trying to, and I work in an industrial setting, and I've been trying to find a way of doing this, you know. So, and then you got people out there, they get trolling motors and what have you. The other problem you have with a trolling motor is if you put a trolling motor on a kayak, now you have to have boat numbers. And, you know, I kind of do this, you know, I fly under the radar a little bit with it, I guess you could say. Let's go to ounces. 14, 2. .3 3 12.7. And that was a 3, wasn't it? Yeah. So we're adding this up. So that's 0, that's not high, 0. 30.7 ounces per motor. So you figure you're going under 4 pounds. You're not even going to get close to that weight of 4 pounds in a trolley motor. And not only that, the power consumption is going to be way up there. I use this battery all day. It fits right in my kayak's center piece. I epoxy filled this and put bullet connectors on there. It just makes it easy to remove and remove. But it says it's a gel cell, but it's actually what they call AGM, absorbed glass mat. And that's the number on it. If y'all are interested in getting one of these. Not only that, it's a watercraft battery, so, or personal watercraft battery. So it kind of, and it's orange, matches my kayak, but it's safe in a it's safe in a jet ski or something like that, you know, it's, or certifications or whatever, so it will be fine in a kayak. It was my belief anyhow. So this is where I'm at. What's going to happen in the days to come is I'm going to, these are not, I had to order these from China. They are not expensive. The only thing is they just take a buttload of time to get here. I don't want to destroy these, but what I'm going to do is I'm going to cut this hard inner piece out, and I'm just going to use the outside. I'm going to go ahead and get these done and finished. And I'm going to get the motors mounted in there. We're going to check the wattage and the amperage of what they pull. And then we're going to start doing some thrust tests. See how much thrust one puts out, counter rotator, or the proper rotation, and both polarities. We're going to get that done. We're going to get them on the damn kayak, and we're going to go give them a damn run. We're going to weigh the whole system. I'm going to send links to all this stuff. These, if y'all remember the videos, if you go back and watch the video where I filled these full of epoxy, and the epoxy precipitated through there. And what is that? Hey, spit that out. What'd you just eat? Any of y'all ever got dachshunds? Any of y'all ever had dachshunds? They eat everything. Don't eat anything. Don't eat anything, buddy. That's my little boy right there. Come here, boo. Come on, come on, come on, come on, come on. Oh, you want to play? You don't want to? Come on, come on, come on. All right, let's go. All right. So we're going to get them running. Hey, boo. And we're going to get them running, and we're going to see what kind of thrust they put out, and this, that, and the other thing. We're going to weigh the whole thing down, and we're going to we're going to get it all done. Right, baby? Huh? you like my camera? Okay. We can get it all done, and then we're going to see how it goes. You like? Whoop, whoop. You like? Huh? All right. So, don't eat anything anymore. But that's it, guys. Hit like and subscribe. Y'all have a wonderful day, and we're going to press forward on this. And this is just a little idea of what is going to transpire in the days to come. Thank you very much for watching. Y'all have a good day.